So we are going to start a new topic today. That is design of levers. Up till now, we have seen design of uh, quarter joint and knuckle joint. They are coming under the category of joints. Now we are going to move further. This is one frequently used component in various machineries. That is levers. And if you are going to see the mechanical industry, in that industry, you will find applications of this lever, not only in industry, in mobile sector, in transportation, material handling systems, and process equipments. Everywhere you will find the application of this lever. And how to design that lever and what are the types of that lever that we are going to see in this uh, unit. Not it is not a separate unit actually; it is a separate point from the same unit. So, first of all, I would like to ask one question. How many of you are knowing who has invented this leverage principle? Dhoniram. Hello.
हाँ सर.
My question is that who has invented this leverage principle? Are you knowing what the leverage principle is? What is lever?
No sir.
No. Can you see the screen?
Yes, yes.
Can you, yeah. What you are going to see on screen? Are you going to see
Seesaw type.
elephant and seesaw type? One elephant is standing at one end, and at other end, mouse is standing on that seesaw. Right? What it
Yes sir.
means that mouse is eligible, he is capable to sustain the weight of that elephant. What do
No
you
sir.
understand from this? Huh? Hello?
Sir, elephant weight is higher than mouse.
Higher than mouse. Then also he is sustaining that. म्हणजे पिक्चर चुकीचं आहे का त्याच्यामध्ये काय प्रिन्सिपल आहे, त्याच्यामध्ये काय मॅथमॅटिक्स आहे, त्याच्यामध्ये काय मेकॅनिकल. हा
बरोबर आहे सर. पिक्चर
पिक्चर बरोबर आहे. बरं.
तिथं लेन्सचा फरक असल्यामुळं पॉसिबल आहे.
पॉसिबल. धोंडराम, तुम्हाला काय वाटतं? तुम्हाला लिव्हरेज प्रिन्सिपल माहित नाही म्हणताय तुम्ही.
सर लेंथ जास्त असल्यामुळे ते वेट सस्टेन करू शकतो.
करू शकतो म्हणजे असं मॅथमॅटिक्स मध्ये बसवू शकतो का ह्याला आपण? इंजिनियर सारखं उत्तर देऊ शकतो का? हा बसवू शकतो. कोण म्हटलं काहीतरी मध्ये बोलला आता? काय आहे ते मॅथमॅटिक्स?
लोडच्या अपोजिट साईडची जी लेंथ असेल ती वाढवायची.
लोडच्या अपोजिट साईडची जी लेंथ आहे ती वाढवायची. ओके, ठीक आहे.
आपण परफेक्ट करणार आहे तिथं.
बरोबर. Sumit,
Yes, sir.
who has invented this principle?
Don't know, sir.
Don't know. Okay. Who is knowing that who has invented this principle? It is called as leverage.
Archimedes.
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 Right. कोण आहे? नाव सांगा. कोण बोलला आता? ओंकार.
Onkar power.
Right. Very good. Omkar has given right answer that Archimedes has invented this leverage principle. And based on it, we are going to get mechanical advantage, and every machinery which we are going to use nowadays can be coming under the category
of this principle, or we can say is using this principle, and we are going to get the mechanical advantage. In olden days, this was the principle which was used for constructing various historical buildings. Even you can consider that pyramids in that, and all other historical constructions, where this principle has been used somewhere, either while building of that infrastructure, or while using some transporting devices, or in battle on war front, some principles were used, which are based on this leverage principle. In simple way, we can say this Archimedes has invented this principle. Basically, whether he has invented or not, that is the different part. But he has given mathematical background for this. And as we know that if you are going to give mathematical background to any concept or phenomenon, then it is quite easy to understand to whoever may be studying that principle. Because if you are going to give only description for anything, and if you are going to read it, sometimes it was not possible, sometimes it is not feasible to understand all the things. But mathematics is there, who is going to give a unique language, and by means of which, if you are going to put the things into mathematical formulae, then anybody, he can use that formulae and he can get the same results. That's why mathematics is very important and popular also. And we can say the base of science is the mathematics. And all the phenomena can be put in form of mathematical formulae, and later on that formulas can be validated by conducting experiments. And everybody, those who are conducting that experiment, they are getting same results. That is the beauty. So when that Archimedes has invented this principle, he has used this principle for many applications. Like we can say, you might have solved problems in applied mechanics related to the, what we can say, in statistics and dynamics also, related to the pulleys, the load which we can use at the one end of the pulley, and later on the efforts which are converted by application of that force. So it will get multiplied. Also, if you are going to take the example of gearbox, the gearbox nowadays which we are using in two-wheeler, four-wheeler, automobile, ship, everywhere, even in industries. What is that? That small gear is going to rotate to the big gear. For example, we can consider that the big gear is rotating, and just I will take pen. If suppose we are going to consider that one wheel is going to rotate to the other wheel, and if suppose this wheel is rotated by means of this wheel, and while we are going to count the speed, that is revolutions of this wheel and revolutions of this wheel, we'll call it as a n. We call it as a n1. This as a n2. Then definitely n1 is higher than n2. That means n1 is going to rotate 10 times. Then this n2 is going to rotate 1 time. That means he has to travel for 10 times to achieve the travel which has been done by this. It means that the force which you are going to apply, because as you are told, this distance where the force is applied, here if the force is applied, then this distance and this distance get matter. Okay, this is 1 and this is second, so we'll call it as a L1, and this if you are going to call as a L2, then definitely what we are going to do is that we are going to have the same force, and just you are going to do the multiplication, so that this force which has been generated here, if suppose this gear is going to rotate to another gear, and the force which has been generated, that will be higher than the force which you are going to apply here. Okay, this we will call as a F1 and this F2. And that is the what leverage principle is. That force multiplied by distance is equal to the other side force multiplied by distance. That means this weight of this elephant W will call as a E elephant, and this weight of mouse this will call as a W M, as weight is force, and this distance will call as the distance of elephant LE, and this distance will call as a distance of mouse. And what equation you are going to write? That equation will be E multiplied by what? Fulcrum is here.
WE. WE.
WE. WE multiplied by LE is equal to WM multiplied by LM. Am I right? Hello?
Yes, sir.
Okay. That means this load which has been applied multiplied by distance is equal to small load which has been applied multiplied by distance. If suppose we want to say that we are going to, this WE is very high as compared to the WM, what exactly we have to do? We have to reduce this WE and we have to increase, LE, and we have to increase LM. That means mouse side distance we have to increase and elephant side distance we have to reduce. You might have seen the picture of Archimedes that he is trying to lift earth also. This is earth with the help of this lever. He was just saying that if you are going to give me a suitable fulcrum, alone I will lift that total earth. Because what he needs is the fulcrum and that lever. Then he will be capable to apply such type of force that the total earth will get lifted. So that was his principle. And he has used this principle in many applications at that time for the Greece or for the country. And he has invented too many mechanisms, small machines, by means of which he was doing wonders. Okay, so same thing we are going to learn now in this lever. So what the basically lever is? When we are going to see the lever is a simple mechanical device in the form of straight or curved link. It is written as a straight or curved because right now we are seeing the lever is straight, but it may be curved. It may be right angle also. In some applications, we have seen while we have solved the problems of velocity and acceleration, bell crank lever, that concept we have seen, where we are going to use the same leverage principle by keeping one side small and other side of higher length, and we are going to get the multiplication of that efforts. Likewise, that's why one cannot say it is always straight. So it is curved also, or rigid rod pivoted about the fulcrum. This word is very important. If we are not having suitable fulcrum, then it is not possible to take the mechanical advantage also of any load which is applied. So this fulcrum, that is very important. Okay. So if you are going to see the lever, then lever is a simple mechanical device, and it is mechanical device. Okay. So mechanically we are going to do all the process. Nowadays we are going to have some other methods also by means of which we can do the multiplication. And that are nothing but transformers in case of electrical, or we are going to use some devices like electronic devices where you are going to get the signal which are very weak, and by means of putting the energy in that device, you are going to multiply that signal. So that we can say as a devices which are developed based on this principle, but are used and working with the principle of electric and electronics principles. But here we are going to see this device is totally mechanical, and feasible it is we can develop that device. Okay, and we can get the fulcrum, suitable fulcrum, and we can get the principle of this leverage. It works on the principle of movements and is used to get the mechanical advantage and sometimes to facilitate the application of force in desired direction. So while we are going to see the definition and all the things related to the lever, then the principle is going to remain same. It works on the principle of movements. So how you are going to calculate movement, force multiplied by distance, and that movements are same at the point. With that point we are going to call as a fulcrum point. Okay. Now, if you are going to see the examples of lever, then very first straight Tommy bar used to operate a screw jack. Might have seen so many times that truck drivers, those who are parking their truck at beside the road, and they are suffering to the problem of what you can say they are replacing either the tire or the tire gets punctured, and that's why they are going to use the screw jack and they are going to lift that 10 tons of the truck. But while we are going to lift that 10-ton load with the help of a small device, screw jack, at that time that person alone is going to apply force so that the total load is going to get lifted. Either it is not possible that we can lift that 10 tons, or it is beyond the capacity of human being that he can lift that 10 tons. We don't have Dara Singh also, he is also not possible. Or even big wrestler, it is not possible to lift that 10 tons. But easily we can do that work with the help of a small device, that is screw jack. Definitely in the screw jack we are going to use this principle of leverage, and we are going to do that work. Also in bell crank levers, rocker arms, the part of engine where the opening and closing of valves are done with the help of that total mechanism, that is cam, then push rod, rocker arm, and valves that we are going to see later on. So lever, that are the uses of that lever, and we are going to use mechanically that lever. So one of a question is that, can you give me the answer where again you have seen application of this lever? Anybody of you? Some are explained here, some are told by me. Where you have seen that application of lever?
Fishing rod.
Pardon?
Fishing rod.
Fishing rod. Okay, right. For the fishing rod also, where
Lever.
we are going to use that leverage principle. Okay, if you are going to get a big fish, and if it is not possible to pull out him from water, then you are going to use stick, and with the help of stick and string, you are going to pull him out. Any other application? श्रावण चालू आहे, जरा चांगलं ऍप्लिकेशन सांगा की. हॅलो
सर, शटर वरती करायचं ते फिरवायचं असतं.
कुठलं वैभव, मला समजलं नाही.
ते शटर असते सर दुकानात वरती घ्यायला कडला हे असते फिरवायचं.
ओके, राईट. हँडल वापरतो एक, त्या हँडलला लोड अप्लाय करतो त्यावेळेला ते शटर ऑटोमॅटिक वरती जातं Okay, automatic means by means of applying the gears and all that. Okay, any other application? एक डेली लाईफ मधलं सांगा तुमच्या घरात.
सर
हा बोला.
हापसा पाण्याचा हापसा असतो ना.
पाण्याचा हापसा, व्हेरी गुड. तो पण एक
हा,
आपल्या
तिथं.
अजून girl students, you are using it every day. Not, I am not saying that only girls. I am also today also I have used that. सगळेच आपण, मी चहा केला सकाळी त्यावेळेला मी ते वापरलं लिव्हरेज प्रिन्सिपल. चहाचं पातेलं.
सर
हा बोला.
ती पकड असते पातेलं पकड.
हा बरोबर आहे, सांडशी म्हणतो आपण त्याला. हा मला वाटलं इकडे सांगलीत तुम्ही, आमच्या गावी सांडशी म्हणतो त्याला. तुमच्याकडे काही वेगळा शब्द असला तर काय माहित नाही.
हा बरोबर.
बरोबर आहे ना. ठीक आहे. सांडशी, सांडशी मध्ये पण आपण ते लिव्हरेज प्रिन्सिपल वापरतो. आणि
ट्रॅफिक वाले गाडी उचलायला,
ट्रॅफिक वाल्यांचे
ते फोर व्हीलर वगैरे घेऊन जातात ना ते.
ओके, हा तो जॅकच आहे तो एक. अजून पक्कड किती जणांनी वापरले? पक्कड मध्ये लिव्हरेज प्रिन्सिपल आहे का? आफ्ताब.
हाँ यस सर.
हाँ, कैन यू से
सर बॉटल.
हाँ काय
सर बॉटल ओपनर.
बॉटल ओपनर, व्हेरी गुड, चांगले एक्झाम्पल आहे. अजून हे घरात आपण डबा एखादा आणतो, ते डब्याचं झाकण आपल्याला उघडत नाही, मग आपण चमचा घेतो आणि लिव्हरेज प्रिन्सिपल वापरतो, तिथं उघडतो ते. राईट. आकाश माने,
Yes, sir.
एखादं ऍप्लिकेशन वेअर यूज
Grace pump. Grace pump.
प्रेस पंप.
Tractor grace.
हा,
करून
ग्रीस पंप.
tractor ला.
ग्रीस पंप आपण हँड ग्रीस पंप.
हा.
राईट. ओके, सगळ्यांनीच तो बघितला असेल असं नाही. ठीक आहे, म्हणजे आपण बघितलं लिव्हरेज प्रिन्सिपल किंवा वेअर वी आर गोइंग टू यूज दिस लिव्हर इन ऍक्च्युअल प्रॅक्टिस, अँड we can use what is required actually. If you are knowing these principles, then what you have to do is that you have to invent a new application for that. Sometimes what we are going to do is that already we have discussed a lot on this. Who is designer? Designer is the person who is going to use the resources which are around him, and he is going to develop in it. He is going to create some mechanism or machine who is going to reduce the human effort, right? So that person is called as designer. Not necessary to have the BE degree with him. Sometimes if he is not having any degree, he is also going to invent something, and we can call him as a designer because he is going to use the principles which are there in inverse, and he is going to use the resources around him, and he is going to create new application of that. So that is required. So that is what is expected from every mechanical engineer, and you can have this various applications, and from that applications we can go for the new machinery, new component, new device which we can design. Now, as we have seen these applications of lever, we'll move further. Various types of lever, or before going to types of that lever, we'll just check how the mathematical advantage we are going to get, and how we can put all the things in mathematics. If you are going to see this diagram, then in this diagram we'll start from point A, where some load is applied. That we can take example of that elephant which we have seen in previous picture. That load W is applied, and at point B we are going to apply effort. Okay, So by means of application of that effort, we'll call that effort as a P, and we'll call that external load which you want to lift or which you want to transfer, that W. So this point B and point A, where the effort P is applied and where W load is applied. In between that, we are going to select one point F, which we will call as a fulcrum. Definitely, this P and W are the externally applied loads, and R suffix F, which we are going to call it as a reaction at fulcrum point F. So that RF, that we can calculate by means of knowing P and W. Here, simple mathematical equation we can use, that summation of all vertical forces is equal to 0. So we can write P plus W minus RF, because P is acting in downward direction, W is acting in downward direction, RF is acting in upward direction, which is opposite to this P and W. That's why vertical will call as a negative forces, and downward forces will call as a positive. Related to the forces, already we have seen is positive and negative doesn't matter. Force is remaining force. Okay. But only for sake of understanding direction of that force, we are going to give positive and negative sign. Getting it? So this RF we can write as RF is equal to P plus W. So this RF, here I'll write this equation. This R suffix F is equal to P plus W. Because P and W are acting in the same direction, whereas RF is acting in the opposite of this P and W. That's why we have taken that RF to the other side of equality. And from this we can calculate this reactive force. And if that fulcrum is capable to provide that much reaction, then we can say the equation will get satisfied. Now here, if you want to calculate the mechanical advantage, basically, let me ask one question, that whether we are getting any mechanical advantage in this. What is your concept of mechanical advantage? Anybody of you? Patil. Arshada Patil. Are you there? Hello? Okay. Can you please explain what you mean by mechanical advantage? I'll repeat question. Mechanical advantage म्हणजे काय असतं? Applying low force and getting high force. Okay. That you are going to call as a mechanical advantage. Right. It means that if you are going to apply comparatively very small force for getting or doing some external work, then you are going to call it as you are going to get the mechanical advantage, because what the work is. What the work means? Anybody of you? Force multiplied by displacement. Is it right? It's called as work done. And if you are going to divide it by time, if you are going to measure that work done with respect to time, it is going to become power. Right? If you are going to measure that work done with the help of time as a quantity, that you are going to call as a power. But basically work done is force multiplied by displacement. And this force multiplied by displacement in case of this lever, if you want to keep constant, that is work done while we are going to lift this W, and work done while you are going to apply this effort P, that is equal. That means work done to this side and work done to this side is equal. For example, I will take very simple example. Already I think we have discussed this example in class, that if you want to achieve this height h, and if you want to lift this weight at certain height h against the gravitational force. Otherwise, if the gravity is not there, then easily you can just use your one finger and you can lift that weight. Otherwise, this weight is acting in downward direction, exactly in downward direction. And same weight which you are going to place here, and if you are trying to move this weight in this direction, this we will call as a F2, and the force which you are going to apply, that we will call as a F1. So what will the work done in this case? This work done is equal to F2 multiplied by this distance traveled. This you will call as a S. This F2 multiplied by S. Whereas work done in the second case, it will be F1 multiplied by H. Work done is going to remain same. Where you are going to do work you are doing against the gravitational force. That's why either you are going to apply this force in at certain angle from the horizontal or in vertical direction, that as you applied in this first case, it doesn't matter. Just you are doing work against this gravitational force, where the gravitational force is going to create this W, that is the load. I'll call it as a work WO. Okay, because this W is going to get confused for us. This W and this W. So I'll call it as a work done. This work is done against the gravitational force. In both cases, work done is going to remain same. But in second case, whatever may be the force which you are going to apply, that force will get reduced. This force will get reduced as you are going to increase this S, that is distance travel. Whereas in this second case, this first case, force is high because this H is small as compared to the S. If you are comparing S and H, then H is small as compared to S. That's why F1 is high as compared to the F2. Same principle is used here, that this applied effort P is small than the W, because here the distance which that force has to travel, this distance and this distance, that is while we are going to take movement at point F here, at that time that movement is going to remain same. Again, you can say that why the movement you are going to consider work there, and here you are going to consider movement. Basically, change in movement is nothing but again work done. Am I right? That you are going to call as a momentum. We will not go in detail because I think you might have understood all the concept related to this in applied mechanics only. So that momentum change is again is going to give us the force and power quantity. Here you just consider that the distance traveled by one force is small as compared to the other force, and that's why the efforts which are required or the force which has been applied is small than the other. And here, this as you are going to do this work of lifting of this W, that's why you are going to call as a W which is very high as compared to the applied force P, effort. That's why this load divided by effort, that you are going to get the mechanical advantage. Now little consideration can be done here, and there is chance to ask question. But can we get this mechanical advantage less than 1 at any instant, or whether you have seen some applications where we are going to get the mechanical advantage as a less than 1? Bapat, do you get my question?
Yes, sir.
Have you seen some application where we are going to get the mechanical advantage less than 1? Hmm? Normally, we cannot say that we can't get this mechanical advantage less than 1, but mechanical advantage is never become less than 1, because the load which you are going to lift, load which you are going to move is always higher than the efforts which you are applying. And that's why it is a leverage principle where the leverage is used. In some applications, it can be used to reduce the applied force, to reduce it. In that case, this mechanical advantage will become less than 1. But in normal applications, we are not having this mechanical advantage less than 1. Okay. Do you have any question related to the mechanical advantage? We'll move further. That is leverage. मेकॅनिकल ऍडव्हान्टेज बद्दल कोणाची काही शंका आहे का? हॅलो,
नाही सर.
नाही आहे. Now we'll see then leverage. How much leverage you are going to get? Now this leverage word can be used for many applications, for many concepts also. If you are going to use the leverage principle in earning money, hello, sorry, can you hear me?
Yes, sir.
Okay. I was out of the meeting because I don't know. Let be. So this leverage, that is nothing but the multiplying. That is nothing but increasing. Sometimes this leverage word is used for that purpose. But basically, for the leverage which you are going to get, or the mechanical advantage which you are going to get, that we are going to calculate. And this leverage can be calculated as effort arm length divided by load arm length. That is the length which you are going to use. Here it has been mentioned by L2. This L2 length, which is towards the effort side, and this L1 is towards the force or load side. this ratio, that is L2 divided by L1, we are going to call as a leverage. Now, can you tell me mathematically whether we are going to get different value than the mechanical advantage of this length ratio? Yes? Mathematically, whether we are getting different value for the mechanical advantage and different value for leverage. Hello? Are you listening me?
Yes, sir.
So, whether we are going to get different value. Have you got my question? I will repeat my question. आता आपण जे मेकॅनिकल ऍडव्हान्टेज ही क्वांटिटी मॅथमॅटिकली फाइंड आउट केली ती आणि लिव्हरेज ही क्वांटिटी फाइंड आउट केली ती मॅथमॅटिकली वेगळी असेल म्हणजे त्याचा आपल्याला वेगळा व्हॅल्यू मिळेल आणि दुसऱ्याची वेगळी व्हॅल्यू मिळेल असं असेल का दॅट विल बी सेम
सेम असणार सर.
सेम असणार राईट. पुढचा क्वेश्चन आहे का
बिकॉज आपण मुवमेंट इक्वेट करतो फोर्स इंटू मीन डब्ल्यू इंटू टू एल पी
डब्ल्यू इंटू हा राईट 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 हा. So for others, what he is saying is that as we are going to write the mathematical formulae as W into L1 is equal to P into L2. That's why as we are going to write the equation, so I'll write here that equation. Just a minute. What equation you are going to write here? That this W into L1 is equal to P into L2. So simply what you are going to do, that this P you are going to take to this side and you are going to write equation as W divided by P. What will that second equation? That L2 divided by L1. So W divided by P is going to become equal to the L2 divided by L1. In our case, it will be L to the L1 is towards effort side and L2 is towards load side. So these two values will remain same. Mathematically, we can prove that the mechanical advantage and leverage is the same value which we are going to get, but we are going to use some other parameters. Just we are going to use different parameters to calculate it. Okay, but we are going to get same value. So either you can call it as a mechanical advantage or you can call it as a leverage, which you are going to get from selecting any type of lever. Now, this principle and this application or this mathematics will allow us to use different length and different efforts to do the external work of different type of W by selecting various lengths. Okay, can we move further? Any question related to this? Hello? या स्लाइडवर कोणाला क्वेश्चन आहे का?
नो सर.
No. Can we move further?
Yes.
Okay. Dhoniram, are you there? Hello? अमोल माळी आहे का? हा, काही क्वेश्चन आहे का? अमोल माळी,
Yes, sir.
do you any question?
No, sir.
No. So we'll move further to the next slide. Here we are going to see application of lever in engineering, and same way we are going to say the types of levers. Okay, so while studying various applications of lever in engineering, basically first of all we'll see what are the types of lever which are used in mechanical engineering, and later on we'll see the applications. Okay, sort of that first type is the type where you are going to use fulcrum in between effort and load. What I'm saying is that this first type of lever is type where you are going to use this fulcrum in between effort, that is external force which has applied for doing this external work, this load. Okay, in between these two, if you are going to use the fulcrum, then we'll say it as a one type or first type. First and second, that will be depend upon what the sequence you are going to put, but it is a separate type of lever, and depending upon where you are going to use fulcrum, the lever calculations will get deeper. Are you getting me? I'll repeat it, की आपण fulcrum कुठं ठेवतोय ह्याच्यानुसार आपल्याला वेगवेगळ्या टाईपचे लिव्हर मिळतात. ओके, ह्या केसमध्ये आपण फल्क्रम मध्ये ठेवलाय, म्हणजे लोडच्या आणि एफर्टच्या मध्ये जर फल्क्रम ठेवला तर वी आर गोइंग टू कॉल इट एज अ फर्स्ट टाइप ऑफ लिव्हर. ओके, नाउ हियर सम प्रॅक्टिकल ऍप्लिकेशन्स आर मेन्शन. यू कॅन सी हियर दिस hammer. This hammer here you are going to use effort, and here is actual load which we are going to use. Are you able to listen me? Hello?
Yes, yes.
Okay. So, and fulcrum is used here. This is a very critical application of first type of lever. You can see, because fulcrum is in between this applied effort and external load. Okay, if you are going to make this as a bell crank lever, okay, fulcrum is used at this point. So applied effort and load. Very simple example which we can see, that is in scissor, where the fulcrum is used at in between. This is applied effort and this is load, where we are going to cut anything that we can say. So in tin smithy you might have seen, to cut a thin Are you able to listen me? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Thin metallic sheet we are going to cut with the help of scissor, right? So that metallic sheet, as compared to what we can say paper, it is very hard to cut. Then also with the help of scissor, you are going to cut that thin metallic sheet, where we are going to see the first type of application is there. And in most of the application, this first type of lever is used only, where the fulcrum is in between that applied load and applied effort. In that case, while we are going to calculate this reaction at the fulcrum, that you are going to calculate with the help of this RF is equal to W plus P. So this equation is playing very important role while we are selecting, while we are designing of these levers. Okay. So do you have any question related to this?
No, sir.
So we'll move further. We have named it as a second type of lever. In case of this second type of lever, this effort is put in between fulcrum and applied load. The question is that whether we are going to get the mechanical advantage in this. Yes, here also we are going to get the mechanical advantage. Okay. In this case, applied effort should be less than the external load. So in this case, where we are going to use is fulcrum at the one end, and in between that effort, you are going to put the load, external load. Very, very, very popular and simple example. Okay, it is Marathi is called as Adkitta, right?
Right.
Everybody might have seen it. Am I right?
Yes, sir.
Yes. And second example on construction site, you might have seen to have this to lift this higher load. We are going to use W is higher as compared to the effort which has applied by this person, right? So this is second type of lever. Now here, while you are going to calculate the reaction at fulcrum, then this W is in the opposite direction of F, this applied effort. That's why, as already we are knowing that W is higher than the effort. That's why W minus P is the reaction which we are going to get at the fulcrum point. Here, if you are going to compare the equation which we have derived previously for the RF, which is RF is equal to W plus P. And in this case, we are going to get this RF is equal to W minus P. In same levers, if you are going to say, in same application, if suppose first of all, I choose the first type of lever, and if suppose you choose the second type of lever, what difference you are going to get here as far as this fulcrum reaction is considered? Same application, that is W is same, P is same. And if I choose first lever, and if you choose second type of lever, which design is better? Whether it is my design or it's yours? Are you getting my question? माझा क्वेश्चन असा आहे की एक सेम ऍप्लिकेशन आहे ज्याच्यामध्ये W आणि P सेम आहे. मी काय केलं की फर्स्ट टाइपचा लिव्हर तिथे यूज केला आणि तुम्ही काय केला की तुम्ही हुशार आहे माझ्यापेक्षा, त्याच्यामुळे तुम्ही सेकंड टाइपचा लिव्हर यूज केला तिथे. दोन्ही डिझाईन मधलं कुठलं डिझाईन प्रेफर असेल?
सेकंड.
सेकंड. कशासाठी, कशामुळे?
कारण जो वेट आहे ते मध्ये असणार आहे, त्याच्यामुळे आपण दोन सपोर्टच्या मध्ये असल्यावर ते जास्त स्टेबल राहतं लोड.
राईट, एक स्टॅबिलिटी हा पॉइंट आहे. दुसरा अजून मी एक स्टेटमेंट करतो, रेकॉर्डिंग चालूच आहे. मी तुम्हाला नवीन काहीच शिकवत नाही, तुम्हाला जे माहिती आहे ते फक्त अरेंज कसं करायचं हे शिकवतोय. ओके, ही पहिली गोष्ट. दुसरी गोष्ट की मी नवीन शिकवण्यापेक्षा जे आहे ते तुम्ही यूज करायला शिकला पाहिजे. तुम्ही त्याच्यातनं एखादं नवीन इनोव्हेशन करायला शिकलं पाहिजे, असं माझं मत आहे. आता सांगितलं ते बरोबर आहे की स्टॅबिलिटी हा एक पॉइंट आहे. दुसरा काय पॉइंट असू शकतो? उत्तर हे पण बरोबर आहे की दुसऱ्या सेकंड टाइपचे लिव्हर प्रेफरेबल आहे.
सर फलक्रम पासून फोर्सचं डिस्टन्स लांब पडतंय थोडं
पहिल्या टाइपपेक्षा जास्त लांब पडत आहे. त्याच्यामुळे काय?
त्यामुळे सर फोर्स कमी लागणार.
फोर्स कमी लावावा लागणार. बरोबर. ओके, अजून
लेंथ ऑफ रॉड कमी होती सर.
लेंथ ऑफ रॉड कमी होईल म्हणजे मटेरियल कमी लागेल, स्वस्त होईल. अजून फल्क्रमच्या रिएक्शनवर काय परिणाम होईल का? पहिल्या टाईपच्या लिव्हर मध्ये रिएक्शन कमी असेल का जास्त असेल?
जास्त असणार.
जास्त असणार सेकंड टाईप पेक्षा. जिथं रिएक्शन म्हणजे फोर्स जास्त आहे तिथं स्ट्रेस जास्त असतो. डिझाईन मध्ये शिकलो सगळ्या. जिथं स्ट्रेस जास्त आहे तिथं काय जास्त ठेवावं लागतं मग?
फॅक्टर ऑफ सेफ्टी.
फॅक्टर ऑफ सेफ्टी जास्त पाहिजे. बरं, अजून स्ट्रेस इज इक्वल टू फोर्स डिवाइड बाय एरिया. जिथं स्ट्रेस जास्त आहे तिथं
एरिया कमी ठेवावा लागणार.
कमी नाही जास्त ठेवावं लागणार ना. स्ट्रेस सस्टेन दॅट
सर जास्त ठेवावा लागणार.
जास्त ठेवावं लागणार फॉर सेम फोर्स. ओके, जिथं स्ट्रेस जास्त आहे तिथे एरिया जास्त येणार मग, म्हणजे मटेरियल जास्त आलं. म्हणजे फल्क्रमवरची रिएक्शन ही कमी असणार आहे सेकंड टाईप मध्ये. दॅट्स वाय सेकंड इज प्रेफरेबल. दुसरं स्टॅबिलिटी सांगितली तुम्ही, लिव्हरची लेंथ सांगितली, then all that will get reduced, and hence it is possible to reduce the cost of that again equipment, total device. Barabar? So likewise you have to just think about it. Okay, we'll move further. Third type of lever, where effort is put in between that fulcrum and external applied load. Have you seen such type of applications where we are going to put that effort in between fulcrum and that applied load? Hello?
Yes. Yes, sir.
Where you are seeing? Hello?
Yes, sir.
Application? Stapler, right? Very good.
Stapler.
Very basic example is shown here. See, for the
चपात्या वाजायचं, चपात्या उचलायचं.
right.
चिमटा.
हा जो झाडू दाखवलाय, हा झाडू या ठिकाणी वरचा हात हा फल्क्रम सारखा ऍक्ट होतो आणि हा जो खालचा हात आहे जिथं आपण एफर्ट लावणार आहे तिथे एफर्ट लावले जातात आणि ऍक्च्युअली वर्क डन इथं असतं. वेअर फल्क्रम इज ॲट वन एंड. बरोबर आहे? त्या केसमध्ये सुद्धा वी आर गोइंग टू गेट द मेकॅनिकल ऍडव्हान्टेज, हायर मेकॅनिकल ऍडव्हान्टेज. इन दॅट केस applied force is less than externally applied load, W. But while we are going to calculate the reactive force at fulcrum, we are going to calculate it as P minus W. Okay. आता हे सगळं पहिल्या स्लाइड पासून आपण बघितलं तर P आणि W एका डायरेक्शनला ऍक्ट होत आहेत म्हणून आपण RF, that is upward force is positive and downward force is negative. Basically this equation is this RF minus P minus W is equal to 0. This is equation. And this P and W has taken to the other side. That's why this W plus P is equal to RF. The second slide also, this W which is acting in downward direction, that we have considered negative, and this upward force RF is positive. That's why this equation is basically what? RF plus P, which is in upward direction, minus W is equal to 0. This is the basic equation. From this equation is derived. Likewise, here also we can write this P, which is in upward direction, minus RF minus W is equal to 0. And if you want to calculate this RF, this W is taken to the opposite side and P is taken to the opposite side. It is better to take this RF only to the other side. That's why this RF is equal to P minus W. Here, we may get negative value of RF. What it means? Negative value of RF means what will be the negative sign indication in this case? जर RF ची व्हॅल्यू आपल्याला निगेटिव्ह मिळाली तर ह्या केसमध्ये आपण काय म्हणायचं? हॅलो,
फोर्स रिएक्शन डाऊनवर्ड डायरेक्शनला असेल.
हा बरोबर. जर RF व्हॅल्यू आपल्याला निगेटिव्ह मिळाली तर त्याचा अर्थ आहे की RF जो आपण डाऊनवर्ड कन्सिडर केलाय तो डाऊनवर्ड नाही, तो अपवर्ड आहे. ओके. आणि जर RF आपल्याला पॉझिटिव्ह व्हॅल्यू मिळाली तर आपण डिसाइड केलेली, आपण कन्सिडर केलेली डायरेक्शन बरोबर आहे. म्हणजे जी डाऊनवर्ड डायरेक्शन आपण RF ची कन्सिडर केली while सॉल्व्हिंग प्रॉब्लेम, हे बरोबर आहे. जर आपल्याला निगेटिव्ह व्हॅल्यू मिळाली RF ची तर हा फोर्स अपवर्ड डायरेक्शनला ऍक्ट होतोय. एवढंच त्याचं मिनिंग आहे. ओके. म्हणजे RF रिएक्शन हे आपण कन्सिडर केलेल्यापेक्षा विरुद्ध दिशेला आहे. Got it?
Yes, sir.
Okay. So these are the
Sir,
yes.
sir, spoon ते एक्झाम्पल घ्यायचं होतं ना.
स्पूनचे एक्झाम्पल जर घेतलं तर लोड कुठे आणि एफर्ट कुठे आणि फुलक्रम कुठे? बेसिकली स्पून हा लिव्हरचा एक्झाम्पल होऊ शकतो का? स्पून मध्ये असलेले पोहे हे झाला W, हातात धरलेला तो फुलक्रम म्हणायचा काय अप्लाइड लोड?
सर एका बोटाने आपण सपोर्ट देतो आणि अंगठ्याने आपण उचलतो.
एका बोटाने सपोर्ट देतो आणि अंगठा, हा म्हणजे इनिशियल म्हणजे एकदम ज्यावेळेला आपण प्लेट मधनं पोहे काढताना.
हा सर.
ओके, तो फुलक्रम होऊ शकतो. इन दॅट केस फुलक्रम इज इन बिटवीन लोड अँड अप्लाइड फोर्स. फर्स्ट टाइप ऑफ लिव्हर इट इज राईट.
Okay.
Okay. Any other question?
No sir.
Anybody else?
No, sir.
No. Can we move further?
Yes, sir.
Yes, sir. Yes, yes.
This we have seen straight type of levers. If the lever is of angular type, if angle is in between that applied load and externally, if that external load is there is some angle. These type of levers we are also using in some applications, like while designing brakes of automobile. We are going to use this curve or angular lever. Where we are going to get the leverage principle? Simple example we can take braking system of bicycle.
ST belts.
STP, yes, STP also. Very basic, we can take example of bike and bicycle. Yes, yes.
In bus, sir, that belts.
Bus, bell crank levers are used. Bell, it is not. That's why it is called as bell crank lever.
Okay.
बस मधली जी बेल आहे ना,
Yes, sir.
ती जुन्या जमान्यात असं होतं, जुन्या म्हणजे अजून पण आहे, चर्च मध्ये जी घंटा वाजवली जायची ती घंटा वाजवण्यासाठी ती पहिल्यांदा बेल क्रँक लिव्हर वापरलं जात होती. एका साईडने एफर्ट अप्लाय केला जायचा आणि दुसऱ्या साईडने मध्ये फुलक्रम ठेवून दुसऱ्या साईडने ती घंटा वाजवण्यासाठी ती लिव्हर वापरली जात होती. त्यामुळे त्याला नाव पडलेलं आहे बेल क्रँक लिव्हर.
Yes.
ओके. एसटी बस मधली पण बेल ते लिव्हर जे आहे ती बेल क्रँक लिव्हरच प्रिन्सिपल, म्हणजे त्याला बेल क्रँक लिव्हर म्हणतात. Such type of lever is used. Okay. In that case, as the force is applied at certain angle, Hence, reaction is calculated. Here you can write the formula and reaction can be calculated. Okay, because you have to divide this force, or you have to resolve this force in horizontal and vertical direction. And here you are going to get horizontal and vertical reactions. And when you are going to calculate the resultant of that, that will be the total REF. Are you getting me? In this case, this P is divided. Okay, P is divided, and here we are going to call as a phi angle. Here also we can call it as a phi angle, which again we can derive from this lever angle theta. Okay, how much this phi value will be, that can be calculated in terms of this theta. Basically, here you can say this will also become phi. So this phi will be 180 minus theta. So this phi angle, and you have to resolve this P in horizontal and vertical line. If this is P cos of theta, sorry, phi, and this will be P sine of phi, right? And based on doing all these equations, then afterwards we are going to calculate this resultant. You are knowing how to calculate the resultant. Okay. So this resultant is calculated, that is the reaction at fulcrum, as under root of W square plus P square minus twice of W into P cos theta. Okay. All this multiplication we can do, and we can derive this formula. But directly here we can take, or we can use this formula for calculating reaction at fulcrum while we are using this angular lever. Okay. And last type of lever is bell crank lever, where this theta is going to become 90 degree. This theta is going to become 90 degree. Basically, equation is same as we are derived in first slide, this slide. That cos P theta twice of W, that will become 0 because theta is 90 and cos 90 is 0. 0 multiplied by P is 0, multiplied by W and 2 will become 0. And that's why this equation will get reduced to RF is equal to under root W square plus P square. Am I right? Have you understood it? Okay. Any question related to the types of lever before going to actual design of levers? Any question? Hello?
No, sir.
No.
No,
So just a minute. While we are going to calculate or write the equation, this equation will get differ in various applications or types of that lever, and based on that, the equation, basic equation which you are going to write as a